Hello, everyone, and welcome to Lecture 49, which is about timers. Timers are really important pieces in all sorts of electrical circuits, ranging from small-scale electronics like we are dealing with to really large-scale control using PLCs or motor control or other types of devices. So timers do exactly what you sort of think they would do. And there's a couple of different ways we can use them. One is to introduce precise timing into a process. So if I'm automating a process using digital, analog electronics, programming, whatever I'm doing, what the timer can do is I can have something happen for an exact period of time, or I can create a sequence where things turn on and off over particular moments in time. And there's just a lot of automation possibility. So, for example, having a microwave timer allows me to heat something for 1 or 2 minutes, and I don't have to stand there and watch it. I know that it will stop being cooked at the time that I want to set it to. And obviously there's still the possibility of me setting it for too long or too short of a time, but it's a much more automated process than me having to watch it on a stove. So in this lecture, we're going to introduce 3 basic types of timers, just to kind of get this concept in your head. So the first one that we have here is a simple off-delay timer. And you can see here in this particular diagram, there's actually no semiconductors in here. This is all just inductors, capacitors, switch, voltage, and ground. So in this particular diagram, when I close the switch, what's going to happen? Well, when I close it, immediately it's going to send current along these 2 branches. So the relay coil is a spring, and remember, a relay is a kind of a simpler version of a transistor, and they're very common. And what a relay does, if you haven't seen one before, is there's a coil in it, and when you run electricity across that coil, either AC or DC, it causes it to move. You connect that coil to an armature, and that can act as a switch. And so it's basically a switch that you can activate with electricity. So when I close this physical switch, it activates the relay, which is activating some other circuit, and all is well. At the same time, down here, because it's DC current, we are charging this capacitor. So after this capacitor charges, no more current will run. It will charge up to a max voltage, and everything will sort of stay that way. So this coil will stay with this other circuit locked on that it's controlling, and the capacitor will charge. If I go back and open the switch up again, what's going to happen now? Well, there's no more power going through S1 to the relay coil, but there is power that can come from the capacitor. So the capacitor will discharge through the relay coil and keep it on for an extra amount of time. And that's why this is called off delay. So once I turn it on, it immediately comes on. But then when I open the switch again to turn the circuit off, it will delay that as the capacitor discharges. And we can get really precise with this. We're not going to do the math in this course, but using resistors and capacitors and voltages, if we get those numbers right, we can make this time be extremely precise. The time it will charge and discharge is something that you can calculate with math, but also use circuit simulators to do the math for you. And that's an off-delay timer. Similarly, using semiconductors, we can create an on-delay timer. And what an on-delay timer does is it's really the opposite of an off-delay timer. What I want it to do is like when I close this switch, there's going to be a pause for a certain amount of time, and then the relay will activate after that pause. So the semiconductor elements are here to introduce a pause before we energize the relay coil and activate whatever secondary circuit is attached to this control circuit. So how do we get that pause? Once again, you can see that we have a capacitor. We also have a unijunction transistor. We actually have two capacitors. And the one that's actually truly controlling this is going to be this one. The tricky thing about reading these types of diagrams is things can do more than one thing, and you really have to practice with this in order to truly get comfortable with understanding what a transistor and what a capacitor is going to be doing. So capacitors can act as filters as well as being able to charge and discharge. So this one's acting more as a filter, and this is the one that's charging, because when it charges, because these are all in parallel, it'll apply this voltage, which will then activate the gate at this SCR, which will cause current to go through and open this relay coil. And recall, an SCR is a thyristor, and once this gate is activated, this will stay on until I break the circuit and the gate deactivates. So that's basically how this works. So this resistor and this capacitor, so this resistor is basically limiting how quickly this charges. So once I energize this, it's focused on this branch of the circuit. And it will charge over whatever amount of time I've designed it to charge for. That'll activate the unijunction transistor, which will, in turn, the rest of this will fire, activate the gate, and I will be able to activate the coil. So that is an on-delay timer. And with both on-delay and off-delay timers, to reset it, you need to de-energize the circuit. There's a third type of timer called a pulse timer, which is similar to an on-delay timer, but it is self-resetting, which means that you can kind of repeat the process. And the way this one works is when we basically have these two NPN transistors, and you'll notice that the collector of this one is connected to the emitter of this one. So the rest of this is fairly similar to what we just saw with the on-delay timer. But the thing about it is this, because the collector of this is connected to the emitter, this is basically stealing the current from Q3. So Q2 will, as long as Q2 is on, Q3 cannot turn on. It's basically hogging it all. So once this system activates, if at any point we deactivate Q2, it'll activate Q3, and that'll reset the whole thing. So that's how this thing can kind of reset itself with a pulse timer. So that's really all I want to cover in terms of the basics of timers. Again, they have a ton of uses. And, you know, we can put these timers in sequence so one timer can trigger the next. Again, these are examples of circuits that can be ICs, so we can have multiple timers and build a circuit using timer circuits in order to get more and more control over a process. So that's that. In the next video, we're going to look at the 555 timer, which is a really commonly packaged timer that you can do a lot of things with.